All right, this is a Math Models Unit 9, Lesson 2 video on decay models. And it really only, this lesson really covers one type of decay model, which is what we call half-life. And there's a little bit more about some other things, but the biggest thing that they cover here is going to be half-life. So what a half-life is, just as a brief introduction, is when you have a substance that's a radioactive material, some kind of elemental substance, they don't decay at a rate of like 4 grams per day or something like that. They actually decay in a way that half of it decays in a certain amount of time. And then after that same amount of time, half of what was left decays. So it's not like the same amount decays, it's that half of whatever amount there is decays. And so it requires a different sort of calculation than what we've been dealing with. And so I'm going to use an online calculator. You would be using, again, like a handheld calculator for a lot of this work, but we're going to do an online one where you're going to be able to enter in the information, and it's going to give you the piece that's missing. And so the things that you need to know when you're dealing with these is you're going to have the half-life. And the half-life is the amount of time that this isotope decays one half of its quantity, one half of its amount. So in 63 years, titanium 44 decays half. And then after another 63 years, half of that amount, and so on. So in this, they've given us the half-life, they've given us the time, 500 years, and they've given us the amount that's left after 500 years. We've got to figure out, well, how much did it start with if we ended up with 2.5 grams at the end of 500 years? And so we're going to be jumping to this calculator, and you can enter any 3 out of the 4 values on this calculator. And you're going to have the quantity that remains, which in our example is 2.5 grams. You're going to have, we don't know what the initial quantity is, that's what we're trying to find. You're going to have the time, which in our example is 500 years. 500. And a half-life, which is the time they give us here, 63. When you hit calculate, up here it's going to give you the one for the missing value, whatever it was. And so 612.44 is the amount we had originally. So then all you have to do for each problem after that is just change the half-life time, because everything else about this problem is the same. So I'm just going to go here and do 100.1, I believe it was. Yeah. And calculate. And again, it automatically spits out the initial quantity. So this is very easy using this calculator. So I'll let you finish those on your own. Table 3, it's going to change to where now we're finding the amount after 500 years. So we are given an initial amount, and now we're finding how much is left. So what we're going to do differently, let's go ahead and put our half-life in of 63. And now the time is 500, but what's changed is that we don't know the remaining quantity, and we do know the original quantity. So it's changed it. We know that there was 100 to begin with, but we don't know how much is remaining after 500 years. We calculate, it's going to load 0.4082. And there, what's rounded. So that's our answer right there. And then you do the same for the rest of these 4. That's pretty much it on those. And the rest of these are more problems where you're given a gram, a quantity, a time for the half-life, and a time of the total time, and you're finding what's left. So these are the same type of problem, but with in one problem as opposed to in a chart. So just make sure you're putting the correct values into the correct spot in this calculator, and then leaving one blank, the one you're trying to find, and then it calculates that way. So that gets you through the rest of those. Let's see, number 5. Okay, number 6. A little bit different. The population of largemouth bass in a pond is decreasing at a rate of 10% per year. If the population of largemouth bass is 5,000 this year, what will the population be in 16 years? So it's decreasing by 10% every year. And so you can probably guess the number is going to end up being pretty small. The easiest way to do this is we're going to go to Desmos.com, our calculator. We're going to make this pretty simple. The way this works is we have 5,000 bass, and we're going to multiply it times 90%, 0.90, because after the first year, 90% of them are going to be there and 10% will have gone away. And we want to do that 16 times. Okay? So we're going to do that raised to the 16th power. And when we do that, so notice we did the initial amount times the percentage remaining and raised to the power of the number of years. And so it's 926. Jump over here. And there's our answer right there. So you should be able to do the same thing with number 7. That's pretty straightforward. Put the values in the same spot. And then the rest of these are just identifying the values and what they mean. We talked about this in the last lesson. What's the initial amount? Well, the initial amount is the number outside the parentheses. The decay factor is the number that has been removed. So not 80, but 0.2, because we've taken away 0.2. And then here, the decay rate is the number inside the parentheses. Actually, these are worded. I didn't read it carefully. The decay factor is the number inside the parentheses, whereas the decay rate is the number that you subtracted to get that 0.8. So it would be 0.2 in this case. And that's it for this video.